I'm from Debricked, and I'm gonna talk a bit more about the holistic view of open source vulnerabilities and try to dive down deep into vulnerabilities in the open source that you're using and how to determine if you're vulnerable and taking action on that. But first off, Debricked is a startup based in the southern parts of Sweden. It's based in Malmö. And we were founded in 2018, so it's quite young still. And we're about 25 employees currently, and have taken in some venture capital. But we're still very early in our startup journey and are not done yet, far from. And this guy right there with the worst hair day on photo day is me. And at Debricked, we do three things, or the overall thing we're doing is open source management. So we try to manage and find out what open source you as a company are using. And we look at that in three perspectives: open source vulnerabilities, licensing and copyright, and health as well. Where health is our quality metrics on the open source you're using in a portfolio management perspective. And all this ties together neatly in a policy engine where you can set rules for how you should manage and what is allowed, for instance, licenses, or if you should be notified of particular security vulnerabilities in your continuous integration system. But with that out of the way, let's go into the presentation. And that's what we're going to talk about today. So I have three things on my agenda. I want to give you some insight into the trends of open source vulnerabilities, what's hot right now, and educate you on how to evaluate the performance of open source vulnerability scanners. And then we'll go into see if how we can determine if you're truly affected by a particular vulnerability or not. So to start off, most vulnerabilities comes from the National Vulnerability Database. And for you that are somewhat senior in this environment, this is no news to you. This yearly they disclose about 20,000 vulnerabilities almost, and there has been quite an explosion in the last couple of years in the amount of yearly disclosed vulnerabilities. But we at Debricked, we like to work with specific advisories as well, and I've listed two of my favorite ones here: Friends of PHP and C# announcements. And what we find in these specific advisories is that the quality of those vulnerabilities are a lot higher. They are way more contextualized to the software that is vulnerable, and usually contains more and better information on attack vectors and so on of that particular vulnerability. And we can also see in the graph the GitHub advisory, which is a quite new vulnerability source, but it's still growing and not at all disclosing at the same rate as NVD. But do note that all vulnerability sources here can contain each other's vulnerabilities, and it's very common actually. So beware of duplicates. And from this larger disclosure of vulnerabilities, we can see that there's been quite a shift in what type of vulnerabilities and what weaknesses are being disclosed. In this graph, you can see how many vulnerabilities of each weakness type is being disclosed yearly. And we can see the pink red-ish ones that's trending upwards at the top, which is cross-site scripting. It's becoming a lot more disclosed recently due to the rising popularity of JavaScript, which is a common vulnerability in JavaScript applications. And we can also see that there's a bit of a downwards trend as well in the almighty out-of-bounds operations or buffer overflow, where, for instance, the very famous vulnerability Heartbleed was actually of the bounds of memory buffer type. So how does this affect me, one can ask? And we usually use a vulnerability scanner, such as ourselves, where you integrate and give us access to your code, so we can scan your code and find out what open source you're using, and we map that to those existing vulnerabilities. But it is not completely new, but it's still a very maturing space. And we actually like to reason around the quality of the vulnerabilities in 4 layers, or the 4 levels of true positives. And this is actually adopted by Linux Foundation with our contribution. And we want to understand the quality of those open source scanners and the capabilities of them and what they're actually solving. So the 4 layers are at the very top. Are you using a vulnerable package and the vulnerable version of that package? There's usually some false positives in tools where you get notification that you're vulnerable, but you realize that, okay, it's mismatched on the version, or it's matched on a completely different package that not the package that you're actually using. And this is an industry problem today, but I'll go a bit deeper into this. And then at level 2, we have, are you using the vulnerable code of that vulnerable package? At layer 3, we have, is the vulnerable called during runtime? And in the 4th and final layer, is the code exploitable in a critical environment? Let's start off by looking at layer 1. So there are some challenges here currently in the industry, where there are, for instance, first off, different standards for how vulnerabilities are disclosed and how you map that to a software, and for how you install software through dependency managers such as pip and npm. Vulnerabilities are disclosed together with a CPE, a common platform enumeration. And this is a unique identifier for a particular software and a particular version. And that sounds great, but this is not, CPEs are not what package managers are using. They're usually using something custom or a PURL, which is a different standard, where these 2 standards actually don't overlap. And it's a quite challenge to match CPEs with PURLs and find the correct software to a certain dependency or a certain vulnerability. And there's also the part where CVEs or vulnerabilities are disclosed manually, and it contains a lot of manual work to do that. And this means that sometimes there's little to no information or bad information attached to a vulnerability, which makes it very hard to contextualize to your software and correctly understand that, so that you're actually using that software that is vulnerable. And there is also the challenge with duplicate package names. I have this example here, which is I've been fighting a lot personally with. It's the click package. There's actually 2 of them in Python. So here we have a vulnerability, which is clearly a Python vulnerability. You can see that in the first sentence in the description there, where it says that click is vulnerable. But on the right-hand side, we have click, which is a palettes project. That's a CLI builder tool for Python. It's great. I've used it a lot myself. And then there is this other click package, which is not installable through pip and is less used, but still written in Python. So it's actually the left one that is affected by this vulnerability. But since the adoption of the other click package is a lot higher, and it's usually in the requirements files and so on for pip package management, it's really easy to actually match on those. And this is a quite common problem with duplicate names. So let's move on to the next layer, where we have, are you using the vulnerable code, or what code part of a vulnerability is actually vulnerable? So most vulnerabilities in those, the security risk is isolated to a small part of the code base. So I have an example here where we look at Netty, which is a Java component that has two main features. It has compression and decompression, and it has a web server. And there's actually a couple of vulnerabilities in the Netty package. We have a CV here, the decompression part, and we have two vulnerabilities as well in the web server part. So to understand this and match that with our software to understand if we are actually vulnerable, even if we're using Netty and the vulnerable part of Netty, are we using the vulnerable part of the code? So we need to understand which functions, classes are actually vulnerable in the open source package. Are we using them, and how and where are we using them in our code base? So we actually do this automatically at Debricked, where we use our vulnerability database together with our clone of GitHub and all the code, where we first we match the different vulnerabilities with the different versions of the code. So we check out each vulnerable or non-vulnerable commit or release commit, and try to understand those different versions of the code by building a vulnerable abstract syntax tree and a safe abstract syntax tree. And then we understand what has changed in the abstract syntax tree to calculate what are the vulnerable symbols or the vulnerable functions and classes in this particular package between version 1.0.3 and 1.1.0. And this then becomes these vulnerable classes and functions. But of course, we need to contextualize that into the code that we have written as a developer using these open source projects. So from your code, we derive a call graph. And I know it's very hard or impossible to derive an accurate call graph. But in languages where it's easier, such as Go and Java, we are doing this statically. But in languages where it's basically impossible, such as JavaScript and Python, we intend to do this dynamically. And I will get a bit more into that functionality later. So from this, we do a matching of the open source vulnerable functions and classes to if you're using. And of course, it's not only direct calls, it's also nested calls where an open source project are using another open source project, which using a third one, and that's calling a vulnerable function. And this can be displayed in different ways, but this is just sketches for now. We're still in the backend part of this project. But we are thinking of just giving you a flag of whether you are using the vulnerable functionality or not. So here we can see the CV at the top where you're using it is actually the decompression vulnerability, and the other ones are the web server, which we're not using in this project. And to contextualize this into our software, we are showing the files that are calling and the rows of those files that are calling each vulnerable symbol. And here we can see that netty.decompression is called at line 25. And we can also see that authorization.authorize is calling another vulnerable symbol as well, but this authorization.authorize is not the vulnerable symbol itself. It's actually calling it under the hood, but we match that as well. But then we can also see here on the last row that in the test decompression, we are actually calling the vulnerable functionality during tests as well. But this is not as critical since it's only run in a test environment, and we probably don't need to care too much about that, right? And not prioritize that right now. Great. So looking at the third layer, we can ask ourselves if we're using this vulnerable code, not statically, but dynamically during runtime. And we're actually conducting a research project currently together with Elasticys. It's another startup in the northern parts of Sweden, where we are sending the vulnerable classes and functions to the running environment, and tracking and tracing those functions using a technology called eBPF. And this then can be displayed in a nice time series where you can view how much each vulnerable functionality is called. And then looking at the last part, the fourth one, and maybe the most critical one, is the vulnerable code exploitable in a critical environment. And this is a very, very hard challenge, but luckily we have another Swedish startup that's doing great things here. So thank you, Detectify, for solving this challenge for the industry. And lastly, I just want you to remember from this presentation is that monitor language specific advisories. They tend to be of a lot higher quality than the general ones. Especially, I really like the C# announcements because it gives so much more context to the vulnerabilities and how they and updates to when the repository has changed names and so on, which is great. There are different levels of true positives, and we should expect more overall from the industry. Currently at level 1, good vendors have about 80 to 90% precision or true positive rate, and less developed vendors have about 60%. But we should expect that we get through all the layers in the future with vulnerability scanning tools. And to analyze the open source vulnerabilities, you must also understand what part is actually vulnerable and if and how you're using it. Thank you from me. If you have any questions, feel free to ask.
Thank you, Emil. Let me see here. All righty. Just I think I sent it to the right chat that we're eager to hear your questions because we're going to reward some gift card or like a donation to your favorite project based on that. So we do have some. Always fun to start off with something about competitors, I guess. Emil, how do you compare with SNCC?
Yeah, that's our main competitor. So we are quite similar in our offering today to SNCC. But we see that they're moving a lot more into deep security, I'd call that, with container scanning and contextualization of vulnerabilities and so on. And they're doing a pretty good job there. But we are moving into what we call open source management and a broader space and a broader view on the open source you're using. We haven't talked anything about open source health, for instance, today, which we are working quite a lot with, where you can evaluate the quality of an open source project quantitatively. So, for instance, looking at the trend of contributors in a continuous manner, where you maybe want to understand if the open source project, what open source projects are actually the most important ones to you, even though you don't directly import them, and so on, and contextualize that to these open source health metrics, so you can really understand the ecosystem of the open source that you're using.
Great. I hope that answers the questions. Both were quite similar there. I have this one from the registration. So it was, I'm a data scientist with modeling who has found myself working increasingly in security-related investigations. So I'm interested in understanding how I can best leverage my skills for security purposes. Do you have any, Spencer or Emily, have any thoughts?
How one can best leverage their skills for security purposes?
Yeah, they are a data scientist with a specialization in predictive modeling.
Yeah. Like, that's exactly like what I'm doing. And I can just tell you a bit about other things at Debricked that we're looking at with our whole clone of all open source. Basically, we are using a lot of machine learning to look at commits on code, on pull requests, on issues with NLP, or or NLP for code, where we are trying to predict and find undisclosed vulnerabilities, which is quite close to what Spencer presented. And we, of course, want to disclose them in a responsible manner. For instance, we have one algorithm where we look at issues, and we estimate that we find about 400,000 or 500,000 security-related issues on from different sources, and that's quite nice to compare to the less than 200,000 total disclosed vulnerabilities in open source. So I think there's a lot of opportunity in this space.
Definitely. And we have 2 questions. Woo. Can you elaborate from Anders? 2 questions here. Can you elaborate a little bit on the false positive of Debricked? Can you guarantee almost 0 FP rate with your verification process? And secondly, do you cover transitive dependencies as well?
Yeah, so let's start with the second question first. Yes, we have full coverage of your transitive dependencies. So that's great. And it's very hard to reach a 0 false positive rate. And the thing here is that, 1, can we calculate truly accurate abstract syntax trees, and 2, can we derive truly accurate call graphs? And the answer is, of course, no. But I think in terms of false positive rate, I think you should look at it at a risk impact approach, where you can prioritize what you should spend time on. And this really, and with vulnerable functionality, you can see that, okay, these are vulnerabilities that I'm actually using statically, and I can see where. That means I should probably spend more time on those. And in the future, in the short future, where we look at runtime, those are, of course, a lot more accurate in terms of that we know that these functions has been called. Then there's only the part that we need to find the vulnerable functionality very accurately. And I mean, 0 false positive rate and that we find 100% of all potential vulnerabilities is unrealistic here, I'd say. But this really empowers you to work with the most impactful thing first, and in a short period of time discard things that you're not using.
Great. I hope that satisfied. Let's see here. Yes, thank you for the confirmation, Anders. One more here, Emil, for you. Automation or manual testing for finding vulnerabilities, which one is better according to you?
It's a hard question. I'd say, like, which one is better is really hard. I think that in all your security work, it's not about one or the other. It's about doing the most impactful thing for your security. If you spend all your time only doing security work on your application, you probably don't have enough resources to actually develop it for the future. So you have to do what is efficient. And I think automation is really efficient, and do that continuously in your CI and working with that as a part of your DevOps or DevSecOps, and doing manual testing or penetration testing once in a while, I think is really good. And we do that internally for ourselves, of course. And that we usually find stuff, but in our experience, our own tool finds more and better things.
You have any thoughts, Spencer?
So, and this is the Debricked tool. So we integrating to your CI, and then you can choose what repositories you want to perform continuous scanning on. And in this account, we have a couple of repositories. Don't be alarmed by the amount of vulnerabilities. We are not continuously fixing them on this demo account, so it can be quite a lot. But here we can see a couple of different views. We have the repositories view, vulnerabilities, view all dependencies, and the licenses. the open source you're using. If we check out repository here, we can see some vulnerabilities here. And then we show some information on the CVSS. We have our own Deb AI, which is a custom weighting of the CVS score. So you can contextualize the vulnerabilities to how you use your software. For example, if it's an internal tool, you may not want to weight denial of service type of attacks in the CVSS score high, for instance. So then you can reweight that so it's more contextualized to your application. We can see if we have reviewed it and taken any action on it. We have two that we have deemed vulnerable here. So let's check one of them out. And here you can see that this one, we can see the CWE for this particular one. And we have two sources here. We have found it on GitHub and VD. And we can take some type of action here as well, where we can flag it as vulnerable. We can see what particular type or particular dependency and where in our package.json this lives. And here we can see that this ZA proxy is vulnerable with MIME, where the vulnerability is actually in MIME, but it's a transitive vulnerability that is inherited to ZA proxy. And this is what we call a root. This is what we call a root, and there we have the transitive dependency. And we're actually releasing within weeks the capability to perform a pull request. And then we actually update the root dependency so that this MIME transitive dependency becomes this version that is the safe version or higher. And it's very neat. It works quite great in our staging environment. So here we can see some details as well of the CVSS scores. If we have any integration to Jira or GitHub for issues, we can see if someone has changed it. And as we see, I just took action to it, and then it logs that into the activity, so we can track what reviewers of a vulnerability actually has done in this particular vulnerability. And of course, we are developers. We'd like to work where we are comfortable, and especially in terms of that we don't want to spend too much time in different tools, so we can get notified in different places where we actually look in our everyday usage. So here we can create policies in our policy engine. So for instance, if the CVSS is at least high, we can fail the pipeline. And I maybe want to be notified as well. And then we can notify me and write in an email here. And then we can generate a rule. So here we can see that if a dependency contains a vulnerability that has not been marked as unaffected, where the CVSS score is high, we fail the pipeline and we notify this email. And then we save that. And then we can enable and disable these different policies as we want. And we can also monitor our licenses currently as well, where we can see that we have a couple of different licenses here, and we actually contextualize these licenses to how you are using them. So you can configure a use case for each repository, that if you are for instance, if you're a non-distributed internal use only, it really is not too important to monitor licenses. There's just a few of them that can imply risks. But if you are using, for instance, distributed and executed on consumer electronics, GPL v3, for instance, can be can bear quite some risk in terms of what you need, how you need to act in terms of being able to use those open source projects. And then we can see the different risk levels associated with different licenses. And I don't think we have any like AGPLs here, which is usually the most riskful license. And then we can click in and we are filtered on which packages actually use these licenses. And I think, yeah, that's about it.